Okay, next chapter is straight line graphs, pure year 1, chapter 5. Really a lot of this is covered in GCSE, but there is some new stuff which I will talk about over here. So before doing these 4 questions, let's just zoom in on this box that we've got. So first of all, we know that m from y equals mx plus c represents the gradient, and the way that we find the gradient is we do the change in the y coordinates divided by the change in the x coordinates, which sometimes you might see as y1 minus y2, or the other way around, y2 minus y1 over x1 minus x2, as long as you have the first coordinate for the first bit and the second coordinate for the second, or the other way around, as long as it's consistent, that is perfectly okay. Now this is my kind of new equation for the equation of a straight line, and hopefully you remember this one off by heart. It is that y minus y1 equals m brackets x minus x1, and you should find this one is more useful than y equals mx plus c, particularly as we go through to some of the year 2 stuff. Now, we should also know this from GCSE, but if 2 lines are parallel, they have the same gradient. So we can say that they have the same gradient or the same value for m. Now, perpendicular, we know that the gradients would be the negative reciprocal of each other. Now, there is another way that this sometimes gets presented, that if we have the gradient of one line, when you multiply it with the gradient of the other line, if you get -1, then we would say that these 2 lines are perpendicular when you take their gradients. And that's because if you take a reciprocal and multiply it by its non-reciprocal, you get 1, and then obviously there's a negative in there as well. And then sometimes they ask things about it crosses the y-axis at a particular point. Well, we know that it crosses the y-axis when x equals 0, and that it crosses the x-axis when y is equal to 0. So we have got these 4 questions here for the basic section. Let's dive straight in. You might like to try these yourself first and see if you get the same thing as me. So it says, given that the gradient between a 2a and minus a3 is 1/3, find the value of a. Well, I know that my gradient is the change in the y coordinates divided by the change in the x coordinates. Those triangles just mean delta, it means the change in. So I can say that the gradient, which is 1/3, is equal to the change in the y. Now, I'm probably going to do this one minus this one, so that's a 2a minus 3 for the numerator. And then doing it consistently, I did this one, then this one, I will do a minus minus a. So that's a minus minus a. Well, a minus minus a becomes a plus a. So we get that 1/3 is equal to 2a minus 3 all over 2a like this. I'm now going to just multiply this 2a up by 1/3. Well, 2 times 1/3 is 2/3. So we get 2/3 a is equal to 2a minus 3. So all I'm going to do is just a little bit of shuffling some things around. I'm going to do it over here so I have some more space. I will add the 3 to the left-hand side, and then I will do 2a subtract 2/3 a. So 2 take away 2/3, that's 6/3 take away 2/3, that is 4/3 a. And then all I'm going to do now is multiply the 3 by the 3 to get 9, and divide by the 4 so that I get my value of a is 9/4 or 9 over 4. Okay, next one that we've got, it says find the equation of the line which is parallel to this one and it passes through this coordinate. And I will talk about this exam tip in just a second. So we need it to be parallel to this line. I think I need to start off by finding the gradient of that, which means let's make y the subject. So if I add the 3y to the other side, I get that 2x equals 4 plus 3y. I'll subtract the 4 as well, so I get 2x minus 4 is equal to 3y. And then to get y as the subject, I will divide by 3. So that's 2/3 x, just need to divide the 2 by 3. And we get 4/3 is equal to y. So this now tells me, from this line, we can see that the gradient is going to be 2/3. So that means we want our gradient for our line to be 2/3. So we want the gradient to be 2/3. I want it to pass through the point 1/2, 5. Now this is all we need to be able to use this formula. We just need a gradient, and we need the x1, y1. This is my x1 and this is my y1. So the equation of my line will be y minus y1, which is 5, and that is equal to the gradient, which is 2/3, and that is x minus x1, which is 1/2. Now technically we are finished. This is my exam tip. It says unless the question asks for a particular form for the line, you can leave it in its initial form. So I'm going to leave it in this form here. Am I? No, I'm going to rearrange it in case you did some rearranging. So very quickly I will expand the brackets to get 2/3 x, and 2/3 times 1/2 is 1/3, and then I will add the 5 onto the right hand side, so I get 2/3 x plus 16/3. I think that's right. Yeah, 15/3 No, not 16 thirds, because it's going to be minus a third plus 5. So not 16 thirds. I think it will be 14 thirds, won't it? Yeah, that's 5 thirds. 15 thirds minus a third is 14 thirds. But this would have still got you the full marks unless it asked for it in that y equals mx plus c form. So next question, it says a straight line is perpendicular to this. This is kind of the standard form that we will see for equations of lines. You'll see them as y equals mx plus c. You'll see them like this too. So it's perpendicular to this one and it passes through this point, similar to the last question, but we just want to find out where it crosses the x-axis. So because it's perpendicular, let's start off with our 5x minus 2y plus 3. Let's rearrange this to make y the subject. So that's 5x plus 3 equals 2y. I will divide everything by 2 to make y the subject. So I've now got the y as the subject here. So this means the gradient of this line is 5 over 2. Now, if you've watched my videos, when I say perpendicular, I often do m and then 2 little lines and the right angle symbol. The perpendicular to this gradient is the negative reciprocal. So the negative reciprocal, 2/5 instead of 5 over 2, and put the negative in there. Now we've got the gradient and we've got the point that it's passing through. So I'm going to go straight in with my y minus y1, which in this case is the 1 from the 5, 1 coordinate. My gradient, which is my minus 2/5, and then my x minus x1, which is 5. Now I don't need to do any rearranging here because all I want to do is to find out where it crosses the x-axis. So it crosses the x-axis when y equals 0. So I'm going to go to this equation and I'm just going to put 0 in place of y. Well, 0 minus 1 is just minus 1. So I get minus 1 is minus 2/5 x minus 5. Now, some of you might expand the brackets here, which you can do if you want. I'm probably just going to get rid of the negatives from both sides. So I get 1 is equal to 2/5 x minus 5. I'm then going to multiply by the 5 and divide by the 2. So when I multiply by the 5 and divide by the 2, I get left with 5 over 2 is equal to x minus 5. So my last thing that we've got here is to add 5 over 2 and 5 together. So that would be 15 over 2. So it crosses the x-axis at 15 over 2. If we wanted that as a coordinate, we could write it as 15 over 2, 0 for this. Okay, now a slightly trickier one, because we've got some stuff to do with midpoints in here. We have that L1 passes through the points A and B. L2 is perpendicular to L1 and passes through the midpoint of AB. And it crosses the y-axis at the point C. Find the coordinates of C here. So I think first of all, we're going to need to try and find out more about L2. We need to find the equation of L2. And to do that, because it's perpendicular to L1, I'm going to find the gradient of L1, which I'm just going to say is M1 here. Now, using these two things that we've got here, I'm going to do the 3 minus the 4 divided by the 2 minus the 0. If I wanted to, I could do the 4 minus the 3 divided by the 0 minus 2. But I will do what I said originally, so I will do the 3 minus the 4 divided by the 2 minus the 0, so that is minus 1 over 2. Now, because the gradient of the second line, M2, is perpendicular, it will be the negative reciprocal. So it would be, get rid of the negative, the reciprocal is 2 over 1, so I'm just going to write it that it's 2. And it says it passes through the midpoint of AB. So if I'm going to say that the midpoint is M, you remember how you find the midpoint from GCSE? You take the 0 and the 2, you add them together, and you divide by 2. You find their average. So you do the 0 plus the 2, divided by 2. And then for the other one, you'll do the 4 plus the 3, and you'll divide it by 2, which means that our midpoint is 1 and 7 over 2, or 3.5. So now I can come up with the equation of L2. So for the equation of L2, we will do our y minus y1. Remember, it's going this coordinate. This is a lowercase m. This is a capital M for the midpoint that I've got here. So I'm just going to clarify, that is not the gradient, that is the midpoint. I will do y minus the midpoint y, which is 7 over 2, equals the gradient x minus the midpoint x, which is this one that we've got here. And now it is crossing the y-axis. So it crosses the y-axis when x equals 0. So taking the equation we've just written, it will be y equals 7 over 2 equals 2 multiplied by 0 minus 1, which is just minus 1. So that's y minus 7 over 2 equals minus 2. So I will do minus 2 plus 7 over 2, which I believe is 3 over 2. So as a coordinate, point C that we have is 0, 3 over 2 that we've got there. Minus 2 plus 7 over 2 is 3 over 2. So hopefully, pretty straightforward chapter so far. We're going to just now add in some extra bits to do with when they have stuff to do with length, distance between points, and area. Now, to find the distance between two coordinates, I'm just going to fill in this little gap that we've got here. It's basically like Pythagoras. So with your two coordinates, you're going to take the difference between the x coordinates and square them, the difference between or the change in the y coordinates and square them. And I'm just going to note down here, it reminds us of Pythagoras because that's actually where this comes from. So a very quick one for us to do here to find the distance between 5, 9 and 2, 4. The distance is simply going to be, and I would rather you just go straight in by having a look at these, the difference between the 5 and the 2, that is just a 3, and it's a squared. The distance, the difference between the 9 and the 4, it doesn't matter which way round you do it, because you're going to be squaring them anyway. The difference between the 9 and the 4 is a 5, so we get a 3 squared plus a 5 squared. So what's that? A 9 plus 25, that is 34. So we'll leave it as a third here. We have the distance is the square root of 34. Now, we have a slightly more involved question. This is a separate question that we've got here. And this is where I wanted to give you the tip to draw a diagram if it helps you visualize what is going on in the question. It doesn't have to be an accurate diagram at all, just a sketch. So it says the points R, which is 2, 5, and S, which is 4, 0, lie on the straight line L1. So R is 2, 5. Let's just say that it's over here for now. And S is 4, 0. So probably somewhere like this. And it says that they lie on a straight line. Let's do this in a, I don't know, let's do this purple color that we've got here. And I'll see if I can move this around so it's sort of going through the points like this. And that is my equation. That's my line 1 that I've got there. It says that L2 is perpendicular to L1 and it passes through R. So let's do this in this kind of green color that we've got like this. And hopefully it will become a straight line. They are perpendicular to each other like this. And it says that L2 intercepts the y-axis at T. And I'm also going to indicate on my diagram that these are perpendicular because that's a good reminder. And we're going to try and find the area of triangle RST. So I think my last thing to do is to connect those 2 points together. So I've got a bit of a triangle and I'm going to try and find the area of this. Now, because we have a right angle here, we have got the base of the triangle and the height of the triangle. So I think our aim in this question is going to be to find the distance RT and RS. If it's helpful, adding the coordinates onto the diagram can help us remember this rather than having to keep looking back at the question. And in order to find those distances, I think I need to find out where T is. So we know that the L2 is perpendicular to the line L1. So let's begin by finding the gradient between R and S. So I will do the change in Y, so I will do the 5 minus the 0 divided by the 2 minus the 4. So that is a 5 over minus 2, which means that the gradient of L2, I could either write the gradient of the perpendicular, or I could write the gradient of RT. However we want to do this is going to be the negative reciprocal of this, which is 2/5. So now, let's find the equation of L2, which is my green line that I've got there. And we will do y minus, now where's it passing through? We've said it's passing through R. Okay, that's good. It's going through R, and this is the gradient. So it's going to be y minus 5 equals the gradient, brackets, x minus 2. Now, I don't actually need to even rearrange this because I'm just trying to find out where t is. And to find out t, that is where x is equal to 0. Obviously, the x coordinate of t is 0 there. So we get y minus 5 equals 2/5 multiplied by minus 2. So that is going to be these two things multiplied. That's minus 4/5. That is minus 4/5 plus 5. And I'm probably going to say, what's that? 21 over 5. So that is 21 over 5. So now I know that t has the coordinates 0, 21 over 5. Now, if I've got my calculator here, because I'm probably going to need to use the calculator. Yes, I think I can use it. Here we go, I've got this one. Oh, I can always use one on my screen if I can't find it. So we are now going to find out the distance RT. So the distance between R and T is finding out the distance between this coordinate and this coordinate. So for the x part, there's just a 2 squared. And then for the y part, there's the difference between the 5 and the 21 over 5. So 5 minus 21 over 5, you can do that on your calculator. That is 4 over 5, and that's all squared. So I'm just going to very quickly get this on my calculator. So that's the square root of 2 squared plus 4 over 5 squared. And we get 2 root 29 over 5. And then the distance RS that we have, we're going to do in the distance between these 2 points. That is going to be the square root of the difference between the 2 and the 4. Well, that's just a 2 squared. And the difference between the 5 and the 0, that's just a 5 squared. So what's that? A 25 plus 4, that's the square root of 29. So now if we're going to find the area of the triangle, we know that that is going to be the base, which we're saying base and height need to be perpendicular. That's going to be the RT one. So that's 2 root 29 over 5. We're going to do the height of the triangle, which is this bit. As long as base and height are perpendicular, that is root 29. And because it's a triangle, remember you also have to multiply by a half, because if we didn't, we would be finding the area of the whole rectangle. So I'm going to multiply the 2 root 29 over 5 by root 29. And then I'm also going to half that, and we get that the area of the triangle is 29 over 5. And I guess if you did want to have that as a decimal, that is 5.8. And if they asked for units, we can just say that it's units squared for that one. So it's a lot of steps. This is why people find this topic more challenging, simply because there's just a number of steps and kind of organizing your thoughts really, really carefully. Okay, we're going to finish off with a pretty straightforward question, but it's more to show you that they love to have modelling in these exams, and we're going to have a look at something to do with linear modelling here. So the number of inhabitants of a new residential estate is tracked over several years. The population P was measured T years after the estate was built. Exactly 1 year after being built, the population was 120 inhabitants, and exactly 3 years after being built, the population was 260 inhabitants. Using a linear model, that's the big clue, we're going to be using a straight line graph here. Find an equation linking P with T. So, makes sense that we have the time along the bottom and the population along the side. They've said that after 1 year, we've got that the population was 120. And after 3 years, somewhere here roughly, the population has gone up to 260. And again, this is just a sketch to remind us we are looking at a straight line graph like this, okay? Now that we know that it's a straight line graph, we can just pretend where instead of P, we have Y, instead of Y, we have P, and instead of X, we have T. We can just go about finding the equation of this straight line that we've got. Now, you know how we do this. We'll start off by finding the gradient. So normally it's the change in Y over the change in X. This time we will do the change in Y, which is our 260 minus 120. Our change in X, pretty obvious. It's the difference between the change in the T coordinates, which is 3 and 1. 260 take away 120 is 140. 3 minus 1 is 2. So the gradient is 70. And if you think about what this means, this is saying that every year we think that the residential estate is increasing by 70 inhabitants per year. So that was it's not even the end of part A. So we've got the gradient. We can say that one of the coordinates, this coordinate is like a 1, 120. And this is like a 3, 260. You can use either of these, but I will take my gradient. I'll probably do this one because it's a bit easier. And it's usually y minus y1 equals m brackets x minus x1. But instead of y, we're going to have p. So it will be p minus 120 equals 70, t instead of x minus 1. Now I probably will have it as p as the subject because I want the equation to be in terms of p, or p in terms of t, I suppose. I'll expand the brackets on the right hand side, and I'm going to add the 120 to the minus 70, to get 50. Now we can interpret this. This is saying that the population is started off at 50 when it was 0. This y-intercept here appears to be 50. And for each extra year, the population is appearing to increase by 70. So it says, 10 years after being built, the residential estate had a population of 990 inhabitants. Explain whether or not this fact supports the use of the linear model in A. So 10 years after being built, that means that t is equal to 10. Let's use our model to find out what our model predicts. Our model would predict 70 multiplied by 10, because t is 10, plus 50. So our model is only 750 inhabitants. Now that's very far away from 990. So I will say, if it's about 10% within 10% range, but 750 and 990 are not within 10% of each other, I'll say this is not close to 990. So a linear model is not appropriate. And we probably would have had a sense at the beginning that a linear model is not going to be that appropriate. Usually for population, we would tend to think about something being exponential or maybe some other kind of non-linear thing. But to begin with, we're only looking at linear stuff. So maybe linear seemed like a good prediction, but it seems like the population started off linear and then maybe has kind of jumped up a lot faster, going up steeper, because actually it was more like 990, 750. It totally underestimated the population. So that is everything that I think we needed to know from chapter 5 with straight line graphs. And hopefully I will see you in another video soon. The next one I'm going to be making is on chapter 6 for circles.